Okay, guys, so flip over to the side where the table is. I know some of you kind of moved on to the review. But let's go over this. Did y'all hear that beep right there? Yeah. Okay. Now, it seemed like most of you were kind of drawing some conclusions from this. Y'all ready back there?
Yeah.
Okay. So, if you have a degree of 1, what are you talking about with a degree of 1? A line. It's a line. So you might want to do a quick sketch over here just to kind of think through what you're talking about. And this is if the sign of the Lie coefficient is positive, that's what your end behavior would look like. So this is basically saying fill in the box here. It's kind of reverse for what y'all are used to, how it's written usually. But this is saying as x goes to the right, what is your y doing? Infinity, a positive infinity. And then, of course, this would be the other one, negative infinity. What are the maximum number of real zeros? What? 1. Very good. And the maximum number of local mins or maxes? 0, because you don't have any curves almost. It's a straight line, obviously. And then the maximum number of local maximums. So basically, you have no maxes and mins because it's just a straight line. So everybody's good with that. Now, a degree of 2 is a quadratic, right? And it's going to be either opening up or down. I'm going to make this one open up because it is positive 2. So both of these would be what? Positive infinity. What's the maximum number of real zeros? 2. What is the maximum number of minimums? 1. Maximums? 0. Because it opens up, you can only have a minimum. Now, I want to add a column, which is add together the max and mins here. And what do you get? You get a 1, because there's a relationship that we're going to kind of emphasize here. Okay, so how's everybody doing so far?
Good.
Good. Okay, now, if the maximum number of real zeros is 2, what do you know to do right here with the degree? It's going to be a 2. And I kind of talked about that throughout the whole unit, so hopefully you kind of get that. If the sign of the Lie coefficient is negative, this one's going to open down like this. So it's negative infinity, the maximum number of real zeros is 2, 0, and 1, and then we get a 1 here. So the most, like extrema that you can have in this one is a 1. Max and mins are sometimes referred to as extrema. Could you understand why they'd be called extrema, even though it's not a term you may have heard before? Think of like your extremities. What do you think of as your arms, your legs? Okay, they're the outermost parts of the graph, in other words. Okay, now, so everybody's good so far. Let's move on. A degree of 3 with a positive, we know the tails do, or the ends do this, okay? So that means as you go to the right, you're going up. As you go to the left, you're going down. What's the maximum number of real zeros you can have? 3. Now, because it could cross through 3 times. So if I made this one go up and then back down like this, you see how I could get 3? That's my x-axis. So I could get 3. What's the maximum number of local minimums, I should say? 1 and 1, and that gives us a 2. Now, are you starting to see a relationship between the degree and the total of the max and min? It's always 1 less, right? And the number of possible real zeros always equals the degree. So I could go and fill all this in like that, okay? We'll come back. Now, if it's a 4, it means the ends are both up or both down. If this one is up, then this one is also up, and this must be positive. You can have 4 real zeros. Now, you may want to sketch this, because this could do something like this. So there's the possible 4. You may not have 4, but you can have up to 4. How many local mins? 2, local max 1, and then you get a 3 here. Okay, so the next one. If there's 5 real zeros, the degree is 5, and these basically are going to fit with what end behavior family? With a negative Lie coefficient, and it's odd, the ends are doing this, right? From our table the other day. So that means as you go to the right for x, as x goes to infinity, it goes to negative infinity, and the other end goes to positive infinity. And then how many, what's the maximum number of local minimums? So I'm going to have to do more work here, aren't I? Kind of travel around, and then like this. Do you see the 1, 2, 3, 4, 5 possible real zeros? So maximum local minimums is going to be what? And they're going to be 2 and 2 and then equals 4. Okay? So I think y'all are starting to get it. What did you get for this box right here? Number 6. Negative infinity, because it's opening down. 6 real zeros. 2 and then 3. And why? How so? Like why? Why is it 2 and then 3?
Negative.
Yeah, so both ends are going down, and I've got to make up for up to 6 real zeros. There's 1, 2, 3, 4, 5, 6. So it's just the number of like times it has to go up and down. So 3 maxes, 2 mins, giving us 5. Okay, for the rest of this, I'll kind of just fill in, and y'all can let me know if you have any questions. So this is a 7 over here. So you would have to recognize the pattern to know this is an 8 here. So that's something that wasn't real clear there. If that would be a negative, how do I know that's a negative? Yeah. That means that it has to go up more than it does, has to have more of the high points than the low points. So then these are both going to be negative infinity. This is going to be an 8, and there you go. Okay, I'll just fill in the next one. I got 11, positive, and then this is infinity, 11, and then this is 10. Okay, now this one, the driving force here is the end behavior. It's an odd degree polynomial because I'm looking at this very next to the last one. And then the right side is going to go up and the left side is going to go down, meaning I know this is a positive Lie coefficient. Okay. And what about the odd functions? What have we noticed?
That the sign of the leading coefficient in the as x goes.
That's true. Very good. That's very true. These two always match for an odd function. They actually always match for an even function too. Good analysis there. But what else have y'all noticed, like with regard to like the number of maxes and mins? They're the same for an odd function. So you have to kind of realize that this is a 3, this is a 3, making this a 6, making this a what? A 7, and then this would be a 7. Okay? This last one, if I have 4, how'd y'all do on this last one?
Pretty well. 4 and 3.
Okay, now how?
Because it goes up,
Okay,
down, and then up and more.
okay, and what told you that? It's this column right here that says when you go to the left, you're going up, right?
Yeah.
So if your left side or end is going up, and this is positive, so must the right side. This must be an even function.
Yeah.
So it must be an even function, and that means that it's going to open upward, meaning I'm going to have more mins than maxes. So more mins than maxes. This is a 7, this is an 8, and they both go up, and this would be an 8. Okay, so how'd y'all do? Okay, awesome. Very good. Now, you're going to flip over to the back. You're going to work with your partner team on the review for the quiz on Monday. I also want to make sure y'all check the answers from last night's homework. How did that go for y'all? Okay, so you have to check your answers and make sure you ask questions. Also, I will be here Monday morning if y'all need to come in for some extra questions. I think you're going to be fine. In the past, this quiz has always been really a good grade for kids. That doesn't mean don't study.
As Is it harder than
A lot of
last
hundreds usually. No, I think it's easier than one. To me, it's easier. I would think most everybody would think it's easier. So just study hard and come in if you have questions on Monday morning.